Hi. Just to let you know that this is probability review 3. That means it's the third video of probability. The first video has a review and question 1 to 7. Second video has question 8 to 11, and this video will have questions 12 to the end. How many ever we can do from the handout. So let's begin. Two cards are drawn at random without replacement. Without replacement means you're not putting them back from a pack of 52 playing cards. Find the probability of the following. So those who do not know 52 playing cards, the denominations, go to the Google website, find out. Okay. Probability that one of the cards is an ace and the other a queen. So first of all, what I'm going to do is I'm going to write down the total outcome. Total outcome is you randomly pick two cards out of 52. So how many possible combinations are there? 52 C2 combinations are there. And from them, from those 52 combinations, we have to pick up one card, an ace, and the other a queen. So these are the possible combinations for the ace, and these are the possible combinations for a queen, and you multiply them, and that's your answer for A. Both cards are kings. So again, write down, always follow this. Write down the total outcomes first so that you can imagine 52 C2 possibilities are what. And from those possibilities, that's your set. And from within that, you have a subset, which is both cards are kings. So 4 C2. C1 card is a red card and the other a queen. So had it just been picking one card, then this C would have been an easy question, but it becomes very difficult when you're picking two cards. So this is how you break it down. I might be wrong, so anyone's got an easier way to solve this can let me know. So I'm picking a red card, and I'm gonna have the queens which are black queens, that is clubs and spades. Or so this is multiplication. Or I'm gonna have red cards but without the red queens. Yeah, and this time I'm going to have the red queens out here. So there'll be basically 26 C1. So 26 reds, and the two red queens are in this 26, and two black queens. So here, and this would be 52 C2. And this would be reds, but without the queens. Yeah. So that would be 24 C1 into 2C1, because this time I'm picking up two reds, red queens. And this one out here, there's another possibility. See, we got all the red cards, including the queens, going with the black queen. All the red cards, excluding the red queens, going with the red queens. And then you realize that there's a possibility of two red queens. That would be the heart and the diamond. Yeah, red diamond, like that. So then you have, 1C1, 1C1 upon 52C2, like that. You got it? Okay. So basically, this would be red, um, red heart, yeah, with red diamond with red heart, like that. Okay. So that's your answer for C. And for D, it would be first card drawn as an ace, and the second card drawn as queen. So when you have first and second in that order, so far all of these, yeah, um, are are where the order does not matter. Combinations where the order does not matter. So it could be that you have, for example, the first one. If I were to just show you the first one in a non-C format, so it would be like this: 4 by 52 and 4 by 51. Now this would be ace, and this would be queen. Yeah. So I could also have 4 by 52 into 4 by 51, like that, with the first card is queen and then an ace. Understood? So this answer A, B, C, they all have this kind of understanding in it. But when I do, the first card drawn is an ace, so I got 4 by 52. And the second card drawn is a queen, so I got 4 by 51. And that's it. I don't do into 2 factorial out here because this actually means um, 4 by 52, 4 by 51, that is ace and queen. And then the remember the order of combinations of letter arrangements. AQ are 2 letters, so into 2 factorial. Had it been three letters A, Q, and king, for example, and it would have been into 3 factorial, you know. But so out here, that into 2 factorial does not come in the picture because we don't have that queen and ace combinations, just ace and queen. So that's your answer, 30. Yeah. If you want more explanation on this, write to me on my uh, Gmail ID, that is friendlyspider@gmail.com. Got it. So let's move on to the next question. Sorry. With replacement. 2 cards are drawn at random with replacement from a pack of 52 playing cards. And I think I've asked the same questions, but with replacement. That means you're putting back the cards. So this time you got for A, 4 out of 52. And for the queen, you got 4 out of 52 again. And because it is with replacement, you have 52 in the bottom. And you cannot use C out here because C follows uh, a factorial format 52, 51, 50 like that. So this one, you can't do that except the 2 factorial part because you are arranging letters A and Q out here, which means Q and A also has to be considered to be taken into consideration. And if you don't want to follow that, just remember, just try and imagine the total outcome. 52 into 52 total outcomes would be, ace, king, and then the same king and ace would come down again. So if it was hearts out here, it would be hearts out here. It would be diamond out here. It would be diamond out here. You know. So remember, you'll have ace with queen and queen with ace. Same combination again. If you're doing 52, 52. So therefore, 2 factorial. That 2 factorial comes in. If it was 3 letters, it would be 3 factorial. Both cards are kings. So you have 4 by 52 because it's K and K, it's simply 4 by 52 and 4 by 52. Okay, no into 2 factorial. That is not required. Yeah, because they're both K's. This would be similar to you cannot do 4C2 out here. Okay, you can't do that because the C format doesn't apply out here. This would be wrong. So don't apply this. It's this because you're replacing them back. So that same king can come back again. Anyway, C. One card is a red card and the other a queen. So again, a complicated situation, red and queen. Yeah. So I'll do the same thing as I did before, except that it will be 52. So this time it's with black queen. So 2 by 52. Yeah, and obviously into 2 factorial. So don't forget that part. Because you can have the black queen first. And then plus you have the reds, but this time without the red queen. So it'll be 24 by 52. And with red queens. So you got 2 upon 52. And then plus again, you will have queen with the, hearts and queen of diamonds. Yeah. So that would basically mean 1 over 52 and 1 over 52. And then you do into 2 factorial. I forgot the 2 factorial out here. Into 2 factorial out here. And then remember, nowhere in this situation you worked out the Queen of Hearts can also be picked up with Queen of Hearts because you have, it's 52 and 52, remember? So the same can be picked up. So you can have Queen of Hearts and Queen of Hearts, and plus you can have Queen of Diamonds and Queen of Diamonds. So that also can come up. Yeah. So you'll have um, basically you'll have 1 by 52, 1 by 52, and this time remember both are the same cards, so therefore no into 2. Okay. And then again 1 by 52 into 1 by 52. So add them all up and that'll be your answer. So to simplify, C would be, because it's 52, 52, 52, 52 everywhere, I can simply write down 52 by 52 down here. Yeah. And then I simply add up the top part, which is 52 times 2, 104, plus 24 twos are 48, 48 twos are 96, plus I have 2, plus I have 1 out here. Yeah. And I have another 1. So that would be equal to 96 and 400. So 204 by 52 into 52. And then you can reduce it further. So that'll be your answer. Got it? Hmm. Um, Let me see. I'll just try and break it down further. So I've got 4 5s, 4 1s, and 4 13s. And this one comes up to 51 upon whatever the thing is. Yeah, 13 into 52, whatever that comes up. Yeah. And D, the first card drawn, so I'll just put it out here. D is first card drawn is an ace, and the second card drawn is a queen with replacement. So ace and queen, and I won't be doing into 2 factorial. That's my answer. Yeah, that's it. Moving on to question 14. What is the probability that at least 2 team members have their birthdays in the same month, given that there are 20 team members in total? Same month. So January, February, March, April, May, June, July, August, September, October, November, December. 3, 3, 3, 3, 12. So there are 12 months, and the question is at least 2 team members having their birthdays have their birthdays in the same month. What is the probability of that? So we'll take best case scenario, worst case scenario. Best case scenario, that all the 20 team members have their birthdays in any one of these months. So let's just say it was in the month of January. It could be any of the 12 months. So I'm picking up January. So in January, all the 20 team members have the birthdays. And so I'm going to ask the question again, what is the probability that at least 2 team members, so 20 is at least 2, so it is more than equal to 2, 20 is more than equal to 2, have the birthdays in the same month. So it is in the same month. So this is the best case scenario. And the worst case scenario. Worst case scenario, I'll put it out here on the bottom. So I say 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So there are 12 people who have their birthdays in 12 different months. Okay. But then I have 20 team members. So there are remaining 8 people. So 8 people will obviously fall into any one of these categories, right? I will go in this order, but you could pick any of the 8 months out of the 12 months, and then you realize that at least 2 team members, so there are at least 2 team members, there's 2 members or more than 2 members, have their birthdays in the same month. So it is in the same month. So obviously the spread is such that in the worst case scenario, I've picked up the worst case scenario. Okay, so I could have very well had all of these 8 out here falling in the same month, but I've picked up the worst case scenario, so I've spread them over the 12 months, and so I do satisfy the question again, and so my answer is 100% or 1. The answer is 1. There's always a possibility. So always ask yourself a question like, okay, what if there are 8 team members and not 20? So what is the probability that at least 2 team members have the birthdays in the same month? So worst case scenario, I could have picked up 8 people in any of the 12 months. So at least 2 people, the probability would be zero. But in the best case scenario, I could have had all the 8 people in the same month. And what I would have found out is that I would probably get two answers depending on the situation. Yeah. One could be zero, one could be 100%. But let's move on to the next question. An egg tray consists of 6 eggs from which 2 eggs are broken. So I've got 2 eggs broken and 4 eggs which are in perfect condition. If 2 eggs are taken out at random, so out of 6 eggs, if 2 eggs are taken at random, so 6C2 are the possible combinations. Yeah. What's probably that both eggs are not broken? Not broken is 4C2. So that's my answer. So that would be 4 into 3 upon 1 into 2, and then upon 6 into 5 upon 1 into 2. So this is 6 goes into this 2 times 2 by 5. 40% or 2 by 5 is my answer. That was easy. A factory manufactures club soda in pack of 6 bottles. So whole pack is rejected if even if one bottle has a manufacturing defect. Yeah. If the probability of a bottle being defective is 20%, so non-defective is obviously 80%, then find the probability that a randomly selected pack of club soda is not rejected. So not rejected, there are 6 of them. Yeah. So remember, it will be 6 factorial by 6 factorial into 4 over 5 because they should not be rejected. That means they should not be defective. All of them should be in perfect condition. So that's my answer. 4 over 5 to the power 6. In other words, 4 to the power 6 upon 5 to the power 6. That's my answer. And that's it. That's the last question now. A school consists of 5 playing grounds. 2 grounds are for football or hockey, 1 ground for volleyball or baseball, 1 ground for cricket, and one for tennis. If a ground is selected at random, find the probability that a game of football will be played. So I'd like to correct this statement. Find the probability that a game of football will be played. Okay. So let me just rephrase this question. In the question, assume that um, if you're selecting a ground, then some game is always being played on that ground. Okay. Yeah. So it's either football or hockey on those 2 grounds. Yeah. And then there are the remaining 3 grounds where they have volleyball or baseball, one for cricket and one for tennis. So if a ground is selected at random, find the probability that a game of football will be played. So first of all, football has 2 grounds. Football or hockey has 2 grounds. So out of 5, probability that a football game is played is first you have to select the number of grounds where the football is being played. So 2 out of 5. Then multiply that with the probability that on those 2 grounds we can have both people playing football. I mean both games being football being played on that ground. Then दोनों hockey भी हो सकता है. Yeah. Football on ground one, hockey on ground two, and hockey on ground one and football on ground two. These are the possible combinations you can have on ground one and two. So the question is, if a ground is selected, a ground meaning 1 ground is selected at random, right? Find the probability the game of football will be played. So out of these 4 combinations, yeah, we can clearly see that there are two combinations, yes, on ground one, and also there are two combinations on ground two. So from these four possibilities, I can clearly see, yeah, that half the time I can have football being played on ground one, and half the time I can see that football is being played on ground two. I might be wrong about this into 2 by 4. Yeah, I might be wrong about this. So I'm getting a 20% answer. But you see, I could be right also about the fact that because a single, a ground is selected and a ground is selected and so I have to look at only the possibility of football being played on any one ground. So those who are thinking that चार कॉम्बिनेशन में तीन कॉम्बिनेशंस में तो फुटबॉल है तो 3 out of 4 होना चाहिए ना. Well, it doesn't work that way. Okay, because I'm picking up any one of the grounds, right? Yeah. So if I pick up ground one, then these are the four possible outcomes I can have. If I'm picking up ground two, these are the four possible outcomes I can have. To look at it in another way, is that ground one में hockey या football खेला जाएगा, so that's half the probability out there. या ground two में hockey या football खेला जाएगा, so that's half the probability out there. So I cannot add them up. I can just simply say that ground one select किया तो half होगा. So I can say 2 by 5 into half because 2 by 4 is half. Yeah, because I have picked up any one of the grounds. So any one of the grounds is already picked up out here. And the possibility that football or hockey will be played is half half. So into half I'll do. So that's 1 by 5, 20%. If you have any other way of explaining this thing, and if you think there's a different way you can answer this, or there's a correction to be made, please let me know. Email me, comment, yeah, on my channel, and that's it. All I want to say is I've created a playlist. So in the playlist, in a particular sequence, all my videos will go because I realized I had to do some editing, and owing to which the sequence has gone. You know, it's messed up the sequence in the main videos that would appear on my YouTube channel. So if you go to the playlist, then I have forced the sequence in a particular order. Yeah. So follow that, and you'll have all my videos in a well aligned, orderly fashion rather than the disorderly fashion the videos are there because of some editing I had to do. That's it. Stay tuned. I will probably be working on geometry very soon. And after that, I'll be discussing the June 2025 paper as well. Thank you very much. Bye.